So I'm here today to talk about AMP, which is Google's accelerated mobile project, or Pages project. And for those of you who don't know what AMP is, don't worry, I'll give a full rundown of it and kind of give a talk about, in particular, what it is and what makes AMP so fast. So first off, what is AMP? Like I mentioned, AMP is accelerated mobile pages. It's a project from Google designed to make browsing the web from your mobile device feel lightning fast. Now, most of you probably already have a good sense of why this is important. Faster is better, right? But what most people don't consider, especially on mobile devices, especially in developing countries, is that when you hit a page which takes a long time to load, it actually has a very, very high increase rate on the bounce rate. In fact, after about 10 seconds, more than 60% of people will just abandon loading the page entirely. That means if you go under a Muni tunnel or you lose connectivity briefly and you just hit that spinning icon, chances are that you're actually just going to lose the page entirely and lose that user. So Google decided to try and solve this problem. I'm paraphrasing for them here, but they basically said, we'll give developers a fast, lightweight way to build mobile sites. And that's AMP. You've probably already seen AMP if you've already been searching for news on the web. For example, here's a search for Brexit. And Google pops in this little top stories panel, basically linking to some of their preferred search results. And as you might notice, all of them have this funny little icon saying that they're AMP supported and AMP enabled. And when you actually click through, the experience is almost instantaneous, where you'll instantly hit this mobile page. It won't have to refresh a bunch of times as a bunch of ads load. And you'll immediately see the content that you wanted to see from Google. So like I said, AMP is all about making mobile faster. And we'll dive into some techniques that they actually use to achieve this here in a minute. But first I'd like to talk about what AMP could actually be used for. Now, AMP isn't great for everyone, but it is great for a few key areas. If you're writing any form of content, or particularly static content, like blogs, documentation, or if you're a publisher, AMP is really great, because AMP directly corresponds to more people viewing your content. So folks like the New York Times or Time or BBC, they're all really excited about adding support for AMP. Where AMP doesn't do so hot surrounds building apps. We'll go into how AMP actually works in a second, but it ends up limiting what you can do from JavaScript and CSS pretty radically. So it's mostly focused on people who are trying to get their content into the hands of their viewers. So now that we have a good sense of what AMP actually is, what makes it so fast? It sounds like I've just proposed this sort of miracle library that you can just drop in and sprinkle some magic AMP dust, and then suddenly you'll have a lightning fast mobile site. Well, there are three key kind of tenets that make AMP actually really fast. The first one is that it uses a performance subset of JavaScript and CSS. So on the one hand, it limits what you can do, but on the other hand, everything that you can do will be fairly lightweight. The second is that it enforces only static content. This means it's not good for something like Facebook, where I get a different version of Facebook, then you get a different version of Facebook, then your friend gets a different version of Facebook. It's only for things which are basically the same between visitors across the world. And finally, AMP enforces that there's no third-party blocking, or there's no blocking for third-party scripts. And I'll talk more about what that means in a second. So first up, let's talk about page rendering. What happens when you actually go to an AMP-enabled site and load it? Now, there are two kind of key factors that make up how long it takes to render a page. The first involves how many times that page is recalculated and repainted, right? It's the kind of thing where, say you're loading a page, it starts parsing the HTML and start looking at it, and it says every time it encounters an image or a piece of CSS or an animation, it will actually have to stop, or your browser will have to stop and re-render that page and figure out exactly what needs to be repainted on the screen. As it turns out, this can take a fair amount of time. The second place where you encounter major slowdowns when it comes to page rendering comes from blocking. You're waiting to load some sort of style sheet. You're waiting to load an image. You're waiting to load a piece of JavaScript that's needed to render the rest of the page. So, as you might guess, if there are two rules of AMP, the first rule is no repainting, and the second rule is no blocking. The third rule is going to be no talking about AMP, but it didn't work. In order to do that, they make up a few tricks to make sure that you actually get those two properties. AMP enforces that all content that you're including on your page has to be statically sized. It's not the kind of thing where you'll load an image and just say, hey, grab me this image and try and fit it on the page somewhere. You actually have to say, I want to load this image, and I want it to be 400 by 600 pixels. That way, when the browser is rendering, it can actually go straight through it, set aside a space for it, and then load it later. Additionally, all CSS is n-lined. You can't load it from somewhere else or add more of it dynamically. And they also put a limit on how much CSS you can have. I think it's 65K. Additionally, all iframes are isolated via JavaScript. So you can't load third-party sources willy-nilly. You basically have to decide which pieces of JavaScript you want to load. And from there, AMP will load them in a totally isolated sandbox. It basically ensures that your user won't have to worry about the page refreshing or kind of jumping all over the place as new elements pop in. And remember, that content has to be statically sized. So from the get-go, you have to say how big each iframe is in terms of pixels. So that sounds kind of abstract. I'll just walk through a brief example of what a normal page would look like, as well as a rendering process, and what its AMP-enabled replacement looks like. Here we have a pretty basic HTML page. You're loading some CSS, loading an image, maybe a third-party script. When your browser actually goes to load this page, a couple things happen. It gets through the initial CSS, and then it blocks, right? It has to go check out that CSS from wherever it needs to load it. And then once it's loaded, it actually has to apply that content to the page. Slow. Once it's there, it will actually then go and do the same thing with the image. Since it doesn't know the size of the image, it also has to block while it fetches the image and then repaint once the image is actually loaded. And finally, it'll do the same thing with the JavaScript. Blocks while fetching the JavaScript, blocks while actually executing, and then rendering the JavaScript as well. I think you can see the pattern here. In normal HTML, there's a lot of blocking that happens, unless you do really special things to actually make your page fast. And so AMP makes some changes that allow you, the developer, to write HTML in a speedier way. The first is that they include this little HTML lightning bolt symbol at the top. Doesn't actually make the page faster, but it does tell AMP that this is an AMP-enabled page. Surprisingly, it is required. From there, you have to load AMP's JavaScript so that it knows how to render everything. And then you'll notice that a lot of these images and these iframes have actually been replaced by AMP-related equivalents. Now, these are just thin wrappers over the native HTML elements you get anyway, but they provide some extra validation. So they'll say, oh, I won't actually give you this AMP image unless you specify a width and height. Or I won't let you display this ad unless it's one of our pre-approved list of ad providers. And it also takes a width and height. So hopefully that gives you a better idea of how AMP actually works for page rendering and what most of the JavaScript library is doing. Next, let's talk about the other big factor that slows down mobile browsing: page loads. Now, it'd be hard to talk about page loads without talking about bandwidth, right? And a lot of times people think bandwidth equals speed. You know, if I have like a 10 gigabit Ethernet link, that's better than a 1 gigabit, which is better than a 10 megabit, something like that. And it's pretty much reinforced everywhere, because if you go online and search for something like internet speed test, you're going to get something like this. It's going to tell me, hey, I get 20 megabits down, 22 megabits up, and my ping time is 4 milliseconds. Pretty standard stuff. But what's missing here, and the common misconception, is that bandwidth doesn't actually equal speed. Bandwidth is throughput, right? You can even kind of get it from the unit here. It's megabits per second, the amount of data you're actually pushing through a pipe. And whoever said the internet is a series of tubes wasn't actually that far off. Now, let's say that you're trying to run a train line to make this a little more concrete. You're running your train, and let's do some math about what the throughput is. Bear with me here. Suppose your train takes 10 hours to go from San Francisco to New York City. It's like one of those Hyperloop type of trains. And each train can only carry 100 passengers. So if we're looking at the throughput for it, or the bandwidth, or what's the time or latency for a given passenger to get from one place to the other, you might tell me, well, you know, Calvin, our train can do 10 passengers per hour, right? But the time for a given passenger is 10 hours. If I get on the train and at San Francisco, it'll take me 10 hours until I get to New York. Now, suppose we go back to this example, but instead, each train can carry 200 passengers rather than just 100. Effectively, we've upped the throughput in aggregate, right? Where now we can carry 20 passengers per hour. We've doubled our capacity. But it still takes 10 hours for a single user or a single passenger to get from San Francisco to New York. So for a single person, you haven't actually sped up the time it takes them to get from point A to point B, even though you've upped the bandwidth. And the same thing happens in networks. If we want to get from San Francisco to where our data centers are in Oregon, even increasing the bandwidth won't help us significantly, assuming that our bandwidth isn't saturated. In this case, supposing that I'm trying to make a call from my local computer in San Francisco to Oregon, it'll have to traverse over 10 to 15 different hops in the network, each of which takes anywhere from 5 to 10 milliseconds to traverse. In our case, this ends up being a real bottleneck when it comes to loading content. Now, instead of being able to load as much content as you want, you're practically limited by the intersections between each of these different networks. Ilya Grigorik, on his blog, actually talks in depth about this, saying that latency is kind of the new web performance bottleneck, where it's no longer bandwidth, it's no longer as much page rendering even. It mostly falls around just not being able to load things at kind of this last mile, where you're trying to make a connection to some sort of server. And fundamentally, we're a little bit limited here, right? You can't go faster than the speed of light for actually transferring this information between one point and another. So if I'm talking to a server somewhere in Australia or somewhere in Malaysia, I still have to do a bunch of these round trip times, which each cost me precious milliseconds in order to get the content that I want. But remember, this content is static. There's nothing that says, even though the original server might be in Malaysia, that I can't put that content elsewhere, maybe somewhere even closer to me. And that's what Google takes advantage of. Google basically says, this content is static, so we're going to use a global CDN in order to actually keep this content closer to where the viewers are. And they've actually set up what they call the AMP cache, which any of you as developers can use. You can say, hey, I want to load my AMP-enabled content. I want to hit this public URL. And Google says that any AMP-enabled site, they're freely willing to cache the content for you. Additionally, they'll pre-fetch search results coming from Google-enabled pages and serve everything over HTTP2. So it's allowing you to pipeline most of the content and get it to the end user much more quickly. Finally, let's talk third-party scripts. Now, most of the things I presented here today are static, right? But there are some things that aren't. In particular, those tend to be the things that make publishers money. Namely, advertisements and analytics. Typically for ads, you want to send the ad to the user based upon their behavior, or maybe their demographic information, in order for that ad to do the best. Or if you're collecting analytics data, you want to make sure you're collecting it per user rather than sort of doing this thing in aggregate where the CDN just counts as a single user. To accomplish that, AMP has this idea of pre-bundled advertising and analytics packages. They're essentially a whitelisted set of companies that have pull requested or been added to the AMP repo such that you can use them right out of the box. And it's fairly convenient because it means the user doesn't have to worry about individual ad or analytics tools kind of messing up the page. Because historically speaking, these tools have been some of the worst offenders when it comes to page rendering speed. They often use things like document write, block the page, end up firing off 300 tracking pixels in any given context. They're really heavy. So what AMP said was, we'll provide publishers with an easy way to pull in these analytics, but each one will get their own special iframe, and we're going to do our best to make sure that they're sandboxed and not slowing down the page at all. In order to get this into AMP, all you have to do is pull requests. So you fork the library, add your own code, and then from there, you're off to the races once they approve it and merge it. Now, I'll talk mostly about the analytics session since that's the one I'm more familiar with, but most of the ads fall under the same category. AMP's analytics philosophy is measure once, report to many. Basically, their idea is that you collect your data in a single spot from the user's browser, and then you can send it anywhere else. And at Segment, we realized, hey, this is like very in line with what we do as well. We collect data, send it to a single API, and then fan it out through our servers to many other ones, reducing the user's page load time. And so, slightly shameless plug here, but we actually just announced AMP support 2 days ago as a way to automatically support all of these end tools that haven't yet pull requested the core AMP repo. Essentially, the tracking calls get sent first to our servers and then funneled out to each end tool so that we reduce the initial footprint on the user's page while still allowing you to get kind of this first class view of your analytics data and whatever tools you want, whether they support AMP or no. So that's a quick introduction to Google's accelerated mobile project, or mobile pages project. Hopefully you all got the idea that it's designed to make mobile blinding fast through a series of static rendering, clever tricks when it comes to content caching, and actually making sure that the content is close to the edge. And if you want to check it out, you can actually download and start building an AMP-enabled project today at ampproject.org. They ship with a full validator and library, so it's really easy to get up and running within only a few minutes. And that's AMP. Thank you.